Okay. This is the rundown on the trig modeling packet. Essentially, this entire section of the unit is about ungraphing. So if you have not already done the graphing section, you need to do that in order to be able to do this. Okay, so the problems on the test look like this. At midnight, at high tide, water is 90 feet deep. 6 hours later, at low tide, the water is 10 feet deep. Write an equation that gives the water depth t hours after midnight. So step one is to draw a quick little graph of this situation. Okay, so midnight, we're at 90. We're eventually going to get down to 10. Come on, there we go. Start at 90, goes down to 10, and then it's going to come back up to high tide. We're told low tide is at 6 hours, which means we're back up to a high tide after 12 hours. So then, now that you have this graph, you basically just need to ungraph it. So we need to figure out where's the midline. We need to figure out what's the amplitude. We need to figure out the period. That will help us figure out K. Has there been a horizontal shift? In most of these problems, there is no horizontal shift. And so let's start figuring that out. So the midline is going to be halfway between the min and the max. So you can find that by averaging the min and the max. 90 plus 10 is 100. Divide that by 2, you get 50. So our midline is at 50. The amplitude is the distance from the midline to the maximum. In this case, that's 40. Our period is 12. It takes 12 hours to complete a cycle. So period is 12. And if you remember from graphing, we had this little formula. Period equals 2 pi over k. Now, instead of knowing k from the equation, we know the period, and we're going to figure k out. So we know that the period is 12. Take my word for it, when you solve for k, you get k equals pi over 6. If you need to pause it for a second and see why that's true, go for it. Okay, so then we can write an equation. From the graphing section, we know standard form of a trig equation is a cosine of k times x plus b plus c. And we just need to fill in what we know. A is the amplitude. We know the amplitude is 50. And this cosine cycle started at a maximum, so we know it should be positive 50. Cosine, and then in parentheses, we just figured out that k is pi over 6. There was no horizontal shift, so b is equal to 0. So in the parentheses, it's just pi over 6x. And then c is the midline, and we saw that our midline was 50, which brings me back to an error I made here. We said the amplitude was 40, not 50. So that should be 40 cosine pi over 6x plus 50. And you're done. So the first question on the test is almost exactly like this. And then when in part B, it asks you, when is the water 70 feet deep? So then you're going to take your equation and set it equal to 70. So 70 equals 40 cosine pi over 6x plus 50 plus 50. Okay. So you want to get the cosine function all by itself. So the first thing we're going to do is subtract 50 from both sides. And that's going to give us 20 equals 40 cosine pi over 6x. And then we want to divide both sides by 40 to get the cosine function by itself. So give us 1/2 equals cosine pi over 6x. Okay, so you may be able to go directly to the unit circle and see what the answers are, but just in case, I'm going to do this. So anytime there's stuff inside the parentheses besides the variable by itself, I'm going to make up just a stand-in variable to take its place. And so now this equation becomes 1/2 equals cosine of b. Now you can go to the unit circle. B is cosine is equal to 1/2 at pi over 3 and 5 pi over 3. And the very last thing you do now is to plug back in for what b stood for. So pi over 6x equals pi over 3. To solve for x, you need to multiply both sides by 6 over pi. So all those go away. You get x equals, these pi's cancel, 3 goes into 6 twice, so you get x equals 2. If you do the same thing and you set pi over 6x equal to 5 pi over 3 for the other solution, you are going to get 10. You can work that out on a sheet of paper if you don't believe me. So graphically what that's saying is that if we look at the graph that we drew up here, 70 is right around here. So when the water level first hits 70 feet deep, that happens at hour 2. And when it hits 70 feet again, as it's rising, that's after hour 10. So that's graphically what we're doing when we solve this. Okay. Oh. Look where all my disappearing marker marks went. Okay. Erase. Okay, so you can read the other main type of problem you're going to see here are Ferris wheel problems. So they're going to give you some information. We're going to sketch a little graph, and then we're going to, what I call ungraph that picture. Okay, so in this situation, center of Ferris wheel is 33 feet off the ground. The radius of the Ferris wheel is 24 feet. A full rotation takes 7 minutes. Write an equation that gives the rider's height off the ground after t minutes. So let's just graph this situation. So we know that the midpoint, the center of the Ferris wheel is 33 feet off the ground. And so at their highest point, the rider is going to be 24 feet above that. So 33 plus 24 is 57. So the maximum height off the ground is going to be 57. When they get on the Ferris wheel, they are going to be 33 minus 24 feet. So they're going to be 24 feet below the center. So that's 13 minus 4 is 9. So they're going to be 9 feet off the ground when they first get on. Which makes sense. You need a little space at the bottom of the wheel. Otherwise, the Ferris wheel would hit the ground. And that would not be an enjoyable ride. And they're going to get on the Ferris wheel, and then they're going to go up, and then they're going to come back down. And we're told that the entire ride to go one time around takes 7 minutes. So the period is 7. Okay, so just like we did before, we're going to start figuring out midline, amplitude, all that stuff. So the midline is at 33. The amplitude, so for a Ferris wheel problem, the amplitude is always the radius of the wheel. So here it's 24. You can also do, 57 minus 33. That'll give you 24. There's no horizontal shift, so and the period is 7. And then using period equals 2 pi over k to solve for k, we get that k is 2 pi over 7. So putting that all together into an equation, we're going to have y equals negative 24. So this cosine graph started at a minimum, so we know it needs to be a negative 24. Cosine 2 pi over 7x. And then the midline was 33, so plus 33. And there is our equation. So again, part B gives us a specific height to solve for. So you take your equation and you set that equal to the number they give you. In this case, it's 21. Ooh, it sounds like a fire truck's coming. My dog might howl. It'll be very entertaining for everybody. Okay, so again, you want to get the cosine function by itself, so you subtract 33 from both sides. Subtract 33 from both sides, that gives you negative 12 equals negative 24 cosine 2 pi over 7x. Then you divide both sides by negative 24, gives you 1/2 equals cosine 2 pi over 7x. So again, I'm going to do that little trick where I let b stand for all the stuff inside the parentheses. So you get the simple equation 1/2 equals cosine of b. Again, just like the previous example, you can look on the unit circle. The x-coordinate is equal to positive 1/2 when b equals pi over 3 and 5 pi over 3. Then you just plug back in for what b stood for. 2 pi over 7x equals pi over 3. To solve that, you multiply both sides by 7 over 2 pi. The pi's cancel. And you get x equals 7/6. So after 7/6 of a minute, they are 21 feet off the ground. So that's going to be right around here. And then you can solve for the other solution. Multiply both sides by 7 over 2 pi again. Pi's cancel. And when you simplify this, you get 35/6. So that would be this point over here. 21 feet off the ground. Okay. The last type of problem you're going to see on the test that has to do with this is you're just given a graph and you have to write the equation. So, same deal as always. We're going to find the midline. Then we want to find the amplitude. What's going on? Okay. Wrong one. That was a highly annoying technical problem. Okay, anyway, so midline, amplitude, right? So our midline is at -3. Amplitude is 4. The period, right? So if we want to look at the period, we can pick a spot here. That's at pi over 3. And then the corresponding point here. So this is one full cycle. So you take the ending point, pi over 3, subtract the beginning point, which was -2 pi over 3. Gives you pi over 3 plus 2 pi over 3, which is 3 pi over 3, which is just pi. So the period is pi. To solve for k, you do pi equals 2 pi over k. When you solve for k, you get the k equals 2. So, the trick now is to actually write the function. Just looking at the graph, you can't tell if it's a sine or a cosine function. It's actually, you can write it as either one. I am going to write a cosine function first. I'm going to imagine that the cycle is starting there. So my amplitude is going to be 4 cosine k is 2. The horizontal shift is pi over 3 units to the left, so that's plus pi over 3. And then the midline was -3. There you go. I had to pause to write in the sine version of the same graph. Look at everything is the same. The amplitude is the same, k is the same. The only thing that changes is the horizontal shift. Thanks.